Welcome everybody. Now we are going to discuss demultiplexer. What's demultiplexer? It performs reverse operation of multiplexer. We have seen what is multiplexer. In multiplexer we have many input line and there is only one output line. So in demultiplexer it will be reverse. In demultiplexer you will find single input and many outputs. So demultiplexer accepts single input and distribute that single input over several outputs. So this is block diagram of demultiplexer. So here you can see that there is one input, then we have many outputs. They are labeled like y0, y1 up to yn minus 1, and in demultiplexer we will also have selector line. So selector lines are labeled like S0, S1 up to Sm minus 1. So what will be the role of selector line here? Same as that of in multiplexer. So here what this selector line will do? So this selector line, they are going to select one of the output line. So this selector line will select one of the output line and then incoming data will be sent on that selected output line. For example, if selector lines are all 0, which output line will be selected? Y0. So on Y0 line this input data will be directed. Okay, then let's assume that all these input lines are 1 1 1 1. So in that case what will happen? So this last output line will be selected. Incoming data will be directed to that last output line. So these select lines are responsible to determine which output line, on which output line input data is to be transmitted. So in this figure we can see how many output line. So there are n output line, one input line, and how many selector lines are shown? M selector line. So again there is one relation between number of selector line and number of output line. What will be that relation? Number of output line, that is n, is equal to 2 raised to m. So see, n is equal to 2 raised to m, same as that of multiplexer. Now let's see different types of demultiplexer. We can have different types of demultiplexer like 1:2 demultiplexer, 1:4 demultiplexer, 1:8 demultiplexer, same as that of multiplexer. So 1:2 demultiplexer, it indicates that in this particular demultiplexer we will have how many output line? 2 output line. So in demultiplexer we have also seen that along with the output line we also have selector line. So how many selector line should be present in this particular demultiplexer? So what is the relation between number of output line and number of selector line? Yes, so that relation is n is equal to 2 raised to m. So here what is n? N is nothing but number of output line and m is nothing but number of selector line. Now in this case it is given that n is 2. Okay, we have 2 output lines, so 2 is equal to 2 raised to m. So what should be the value of m here? So here m should be 1. So I can say that in 1:2 demultiplexer we will have how many selector line? We will have total 1 selector line. Now see, this is the block diagram of 1:2 demultiplexer. There is one input I, 2 outputs y0 and y1, and there is one selector line, suppose yes. Then let's try to understand working of this particular demultiplexer with the help of this table. So in this table, first of all, you can find one column which is labeled as yes, that is select line. Okay, it corresponds to this particular select line. Now this select line, there is only one select line, so it can have only 2 values, either 0 or 1. Okay, then there are 2 outputs y0 and y1, so those 2 outputs are shown here. Now if yes is 0, then what is going to happen? So if yes is 0, what will happen? Which output line will be selected? Y0 will be selected. On this output line y0, this incoming data, that is I will be transmitted. Okay, so see, that's why when yes is 0, y0 will be I. So here what is I? It is our input line. Okay, so input line will be transmitted, whatever data present on input line will be transmitted to output line y0 when yes is 0. Okay, and at that time what will be the status of y1? So y1 will be 0. Now consider next possibility when select line is 1. So if select line is 1, what is going to happen? This incoming data, the data which is present on this input line will be directed to which output line? Y1. So when yes is 1, which output line will be selected? Y1 will be selected. Okay, so this incoming data I will be sent on output line y1. Okay, so see here you can see output on y1 like I. Okay, and what will be the output on output line y0? So y0 will be 0. Now let's try to obtain expression for this output y0 and y1. So is it possible to obtain expression for y0 from this table? Yes. So y0 is equal to, so y0 is equal to I. Okay, so what is I? Please try to understand. I means data present on this input line. So it may be either 1 or 0. So y0 is equal to I. So when y0 is I, so y0 is I when yes is 0. So yes is 0. So that's why here I will take yes prime. Okay, so when yes is 0, what will happen with this particular term? So see, I into yes is 0, so 0 prime is nothing but 1. Okay, and 1 into I is nothing but I. So what will be the output y0? So output y0 will be I, right? So this will be the expression for y0. Similarly, can we obtain an expression for y1? Yes, y1 is equal to, yes, y1 is equal to I. So when y1 is equal to I, so y1 is equal to I when yes is 1. So that's why I will take AND operation directly with yes, I into yes. Okay, so see, same expressions are written here. y0 is equal to yes prime into I, and y1 is equal to I into yes, or yes into I. Then this is a logic diagram for 1:2 demultiplexer. So this logic diagram is obtained from this logical expression. See, in order to implement y0, we will require one AND gate and one NOT gate. So see, in order to implement y0, we have used one AND gate and one NOT gate. So what should be the input to the NOT gate? Input to NOT gate should be yes. So yes is given as input to NOT gate. So that here I will get yes prime. Okay, and I is given to as an input to this AND gate, which is other input to this AND gate, yes prime. So AND operation will be performed between yes prime and I. So that is nothing but our y0. Then how we want to calculate y1? So y1 is equal to yes and I. So simply perform AND operation between yes and I, you will get y1. So this is logic diagram for 1:2 demultiplexer. Now let us discuss 1:4 demultiplexer. So in 1:4 demultiplexer, we will have how many output line? 4 output line. Then how many selector lines should be present? So use that equation, n is equal to 2 raised to m. So n is here 4. So what should be the m? M should be 2. So 2 raised to 2, that is 4. So here number of selector line present in 1:4 demultiplexer will be 2. Then this is block diagram of 1:4 demultiplexer. There is one input I. There are 4 outputs y0, y1, y2 and y3. Then in this demultiplexer we will have suppose 2 selector line, and they are labeled as S0 and S1. So this is table which will explain working of 1:4 demultiplexer. So here you can see the select input S1 and S0. Then there are 4 outputs y0, y1, y2 and y3. So in this demultiplexer, when S1 and S0 are 0, 0, what is going to happen? Which output line will be selected? Y0 will be selected. So 0, 0, binary number converted into decimal 0. So I can say that y0 will be selected. On y0 line, which data will be transmitted? This incoming data which is present on input line, I will be transmitted. Means I can say that y0 will be I. Okay, so y0 is equal to I. So here I can be either 1 or 0 whenever S1 and S0 are 0, 0. So see, same thing is shown in this table. When S1 and S0 they are 0, 0, then y0 will be I, and remaining output lines will carry 0. Okay, now consider next possibility. Suppose S1 is 0 and S0 is 1. So what is the decimal equivalent of this 0, 1? So here please try to understand that this S1 is, you have to consider S1 as MSB and S0 as LSB. So what will be the decimal equivalent of this binary number 1? So that's why which output line will be selected? Y1 will be selected. On Y1 line, and this input data will be transmitted. So I can say that Y1 will be I, and remaining output lines will be 0. So see, same thing is shown in this particular row. Okay, so when it is 0, 1, then y1 will be I, and remaining outputs will be 0. Now consider next possibility. Suppose S1 is 1 and S0 is 0. So what is decimal equivalent? 2. So that's why which output line will be selected? Y2. So what will be the value of Y2? So Y2 will be I. Okay, and remaining output lines will be 0. So you can observe same thing in this particular row of this table. Okay, so 1, 0. So that's why y2 will be selected, y2 will become I, and remaining outputs will be 0. Then last possibility, when S1 and S0 both are 1 1, so in that case which output line will be selected? Y3. So Y3 will become I. What will be the value of Y3? So Y3 will be equal to I, and remaining output lines will be 0. So see, same thing is shown in this row. So this is working of 1:4 demultiplexer. Now logical expression for output. So there are 4 outputs. So you will get 4 logical expression, one for Y0, one for Y1, then Y2, and then Y3. So I will not write I have not written that logical expression here. So you can obtain those logical expression from this table. Then after obtaining that logical expression, you are supposed to draw this logic diagram. So this is logic diagram of 1:4 demultiplexer. Now let's try to understand working of this demultiplexer with the help of this logic diagram. So here suppose S1 and S0 both are 0 0. What is going to happen? So here both are 0 0. So output of this NOT gate will be 1 1. Okay. So see, these outputs are connected to this AND gate. Output of this NOT gate is connected to input of this AND gate, as well as output of this NOT gate is also connected to input of this NOT gate. So what will be the value of these two inputs? For this first AND gate, it will be 0 0, and which is third input of this AND gate? It is input I. Okay, so which operation will be performed by this first AND gate? I into 1 into 1. So what will be the output? Output will be I. Okay, so Y0 will carry I, Y0 will be I, and remaining output lines will be 0. Similarly, you can verify working of this demultiplexer for other combinations of selector line.